In the next example, we are looking to solve exponential equations that are in quadratic form. And the ones that you're going to be dealing with will all be something that has a base of e within them. In this case, we can't just take the natural log of both sides, because doing that, we can't take the natural log of 0, and then other things will happen here on the left. So what we're going to do is we're going to use the substitution method, and we are going to let u equal e to the x. And if we let u equal e to the x, here's what happens. In this first term, e to the 2x, this e and this x are going to become u. That exponent of 2 is still there. So this becomes u to the second plus, in this second term, 6e to the x. Again, if we take e to the x and make it u, we get 6u. Then we still have minus 16 equal to 0. So what we've done is we've created a quadratic that we can solve, and we've learned how to do that. So we're going to go ahead and solve this quadratic, and we can solve that using the factoring method, or you can solve using the quadratic formula. As I showed you before, factoring, if it's possible, is a lot faster usually than doing the quadratic formula, but it's your choice. So I'm going to factor this, and this factors into u plus 8 times u minus 2 equal to 0. Then from here I can take u plus 8, set that equal to 0, and I can take u minus 2 and set that equal to 0. And that gives me answers that u is equal to negative 8 and u is equal to 2. Then what I want to do is I want to substitute back to the beginning. And when I say substitute back, I'm coming back to here. U is equal to e to the x. And if I know two answers for u, I'm going to put those back in. So I'm going to get negative 8 equal to e to the x. And I also get 2 is equal to e to the x. And if I go and solve those, now I can go and take that natural log of both sides. And I get the natural log of negative 8 equal to the natural log of e to the x. Using my properties of logs, this x can come out in front, and I get the natural log of negative 8 equal to x times the natural log of e. And remember, the natural log of e, this is just equal to 1. So what I get is x equals the natural log of negative 8. If you try typing the natural log of negative 8 into your calculator, you will see that you get an error. You cannot take the log or the natural log of a negative number. The reason for that is if you think back to evaluating, you're taking e to some power to be a negative number. You're never going to raise something to a power to get a negative. You'll get these small fractions, you could get 1, but you're never going to get those negative numbers. So this one won't work. This answer we can't use. So then let's go solve the other one. If we take the natural log of both sides, we get the natural log of 2 equal to the natural log of e to the x. Moving that x out in front, we get the natural log of 2 equal to x times the natural log of e. Remembering that the natural log of e is just 1, we get the natural log of 2 is equal to x. So x is approximately 0.69. And that's the only answer that will work. If you scroll down to the next one, you can go ahead and try it and then unpause it to check your answer. However, I am going to start you off on this problem just so you can see what happens, and then I'm going to let you finish it. There are two different ways you can start the try this. You can either let u equal e to the x like we did before, and if you do that, you'd get 4 u, oops, let me fix that. 4u to the 4th plus 8u to the 2nd minus 5 equal to 0. Or you could let u equal e to the 2x. And if you let u equal e to the 2x, you end up with 4u to the 2nd plus 8 minus 5 equal to 0. So go ahead, again, either route that you want to take, and go ahead and solve for u, and then eventually solve for x. Let me know if you have questions and I can walk you through it. So pause it now, unpause it when you're ready to check. If you did this correctly, you should get x to be approximately negative 0.346. And again, if you have questions on this, please let me know and I'll come over and walk you through it.